Imagine an artificial intelligence that learns and evolves like biologically intelligent creatures, with human like reasoning, machine speed, and repeatable precision. At Intelligent Artifacts, we've built just that: a revolutionary, fully transparent artificial intelligence, machine learning, and reasoning engine that solves complex problems while remaining human understandable, regulation ready, and scalable to meet a spectrum of needs. The experts insist AI can't do that yet. They're wrong. At Intelligent Artifacts, our approach to machine intelligence is different than what you may have seen before. This demo video will highlight our differentiating features and what we can do for your industry, as well as give you insight into how our technology works. In order to demonstrate our certifiable software solution, we built Mira. A little later, we'll play a game of I Spy with our robot. Mira is equipped with various sensors and serves as an embedded environment to demonstrate the capabilities of our certifiable solution. With the help of Intelligent Artifacts engine and the reasoning module within, Mira will work to detect and identify each object. All demonstrated functionality is supplemented with full visibility into our solution's processes and outcomes. So, what can we do for the aerospace industry? Well, like any sector, you've got problems and areas of opportunity that AI/ML could allow you to solve and explore. For airborne applications in particular, AI/ML must provide assurances of safety in compliance with DO 178C, the international standard for the approval of commercial software-based aerospace systems. No artificial intelligence or machine learning system has yet been certified under this guidance for airborne applications. We intend to be the first reusable, certifiable software component to enable AI/ML and reasoning for airborne applications. Intelligent Artifacts' GAIuS framework is a problem and data agnostic, general-purpose AI/ML-R engine that does not change from application to application. Not only does our engine possess features that simplify or eliminate challenges around DO 178C certifiability, but following initial certification, our subsequent cert kit, the complete documentation of our solution, validated as a software component for use in airborne applications, can be reused across customers, use cases, and platforms, saving you time, money, and providing unparalleled trust and transparency. Although some aspects will need to change with each system, these configuration changes do not require a complete recertification of the engine each time. Features inherent in our system provide a clear path to certifiability under DO 178C, while also aiding in and at times rendering requirements inapplicable for newly proposed guidance specific to AI/ML, particularly around learning assurance. Before we begin our demo, let's briefly walk through the elements that make up our reasoning engine. The IA Reasoning Engine module is general, and all mechanisms therein can be weighted and changed on the fly using a top-down approach, or automatically to optimize situational awareness. The reasoning engine receives a stream of predictions from GAIuS agents. When it is triggered to make a decision or take an action, the semantic manifold begins to automatically populate with hierarchical schemas. You can think of the semantic manifold as a sort of working memory, and schemas as generalized concepts and specific real-world instances of those concepts being pulled from a knowledge base as determined by situational relevance. Weighted mechanisms such as goal states, constraints, and moods are used to determine the specific context around the schemas in the semantic manifold. All of these elements in turn feed into the dynamic decision flow, wherein the module automatically explores possible actions and their effects before making a decision. We'll start by placing multiple objects in Mira's range of vision. As objects appear on the board, the reasoning engine begins to build its world model, displaying concept schemas for the items in its semantic manifold. In the UI, you can modify your view from various sensor feeds, starting with a live color feed of what Mira sees. When you move to the depth view, you can see how Mira separates the background in order to remove the background for segmentation. Once Mira has established depth, it creates a mask around the area of interest. The Objects view gives you the color image of a segmented object. In this case, the most recent object sent through the cognitive processor was this green truck. As new objects are introduced, this feed updates. Now, one of our engineers will play a round of I Spy with Mira. We want Mira to identify the brown fighter jet. The touchpad display on Mira has a list of features to choose from. We'll start by telling Mira that this object has a cockpit. If Mira needs more information, it will ask the most pertinent disambiguating follow-up questions. In this case, the most important question for Mira to ask to reach a conclusion is whether the object is red. Once we answer no, that is all Mira needs to determine that the object we spied was the brown fighter jet. If Mira is unsure, it will continue to ask questions until it has enough information to produce an accurate response. Now that you've seen Mira play the game, we can take a look at what's going on behind the scenes. Predictions from the GAIuS agent onboard Mira are being sent to the reasoning engine module, which uses those models to reason about the current situation, exploring possible actions and their repercussions before deciding on a strategy to take. It is important to note that we do not model input data, but rather we model the smaller prediction output set from the GAIuS agent. We call this just-in-time modeling. Here's where we can highlight a salient Excite AI feature, namely traceability. Our traceability feature provides a complete audit trail from decisions and actions within the reasoning engine all the way to trained data records. The user clicks on an instance schema, in this case, the brown fighter jet, our chosen object. From there, you can view all the salient features of that schema, including the concept that the real-world instance came from, and all of the prediction models from each GAIuS agent node that generated that schema. Prediction ensembles contain the unique ID of each learned record used to generate that prediction. You can select a record's unique ID from the dropdown and trace data from decisions back to predictions from the GAIuS agent, all the way to training records stored in the knowledge base. If you click View Source Image, the engine will produce the training record or records it used to identify the brown fighter jet. In this case, a histogram of gradients was used for pattern matching. If Mira had misidentified the brown fighter jet, you could use the same traceback process to understand what went wrong and delete or modify trained records that caused the erroneous results. Thank you for watching our demo. We hope this helped you to see the versatility of our GAIuS engine and how Intelligent Artifacts is able to provide unparalleled assurances of trust and transparency through our traceback and other Excite AI features. Moving the aerospace industry into the age of AI requires AI/MLR systems that are complex enough to solve difficult problems and safe to implement. GAIuS is a deterministic, explainable, interpretable, and robust solution that allows for traceability to identify what went wrong and editability to fix it. At Intelligent Artifacts, we firmly believe that the future of AI/MLR in aerospace is GAIuS. If you want to learn more about how GAIuS can solve your use case, visit our website and reach out to us using the Request Info button.